Hello everyone, welcome to webinar on analysis and design of steel truss using Midas Gen. I am Nivedita Khole, one of the technical support for Midas IT. If you have any questions, you can write here at the questions box. In this webinar, I was provided with an AutoCAD file, so I'll just show that file. Okay, so this is the drawing file that I received, and with this truss we will be going ahead and making a model in Midas Gen. So I'll open Midas Gen program now. After registration, you can just click on New Project to check if the registration is successful. Now I would like to introduce you firstly to the user interface of Midas Gen program. Midas Gen has got, or Midas programs has got ribbon menu at the top, and this ribbon menu is divided into different segments or tabs. These tabs are arranged as per the work procedure. That makes the user interface very intuitive. All you have to do is go from left to right. Like over here, we have firstly these 4 tabs for So here we have got these first 4 tabs for modeling purpose. Then we go ahead to applying the supports, then apply the loads, analyze the structure, check the results, and then go ahead with the design. Another intuitive feature in Midas Gen is about the workstream menu. In the workstream menu, as you can see, there is nothing over here, it's all blank. This means that we have not done anything inside the workspace. What I mean to say is, at one glance of this works tree, we can understand what all things we have input in the model file. Then we have over here the message window, which tells us about any errors or warnings while we are giving the commands. Over here we have got easy tools for changing the views. This is isometric, front, side, top, and so on. Further, we can change the unit system at any point of time. Over here, I'm keeping this as mm for now for creating our model file. Now, for creating the model in Midas Gen, there are 4 different ways. One is by using the base structures. This is where the wizards are. You can create the truss by using the truss wizard. All you have to do is provide the type of the truss, the diagonal elements, number of panels, length, height, if it's a symmetric or unsymmetric, and then you can even provide the verticals. You can provide the material and section properties at the same time and insert it at any location. So that is about the truss wizard. Secondly, we have got grid lines. We can define grid lines and then we can start creating nodes and elements onto them. Another way of modeling is by starting from scratch. We can use these CAD type of tools, that is creating nodes and elements, and then further editing tools are available. These would be also useful for creating the truss in a regular truss. So now in this session I'll be using the last, that is the 4th type of modeling, that is by using import function. In this import function, you can convert your Tekla files into Tekla or Revit files into Midas Gen text file and import the entire model here. You can import 2D or 3D AutoCAD DXF file. SAP files or STAT files can also be imported. Now, as I received a 2D DXF file, I'll be going for an AutoCAD DXF file import. I'll browse to the same location. The good part in the DXF file was that all the lines were having different layers, and that's how I could easily identify the truss center and put it over here in the selected layers. Then further, the AutoCAD file was in millimeters, so my unit system I have kept it in mm itself, and the scale factor will be 1 for that purpose. Now at the same time, I can go ahead and provide the material and section properties. However, we will be seeing a very good feature of assigning the material and section properties to our model. So all I'm going to do is now change this rotation angle to 90, because in the AutoCAD in the DXF file, the lines were in the XY plane, and in Midas Gen, our XY plane is horizontal. We need to rotate this XY plane to XZ plane, and that's why I have made the rotation about the X axis as 90 degrees. Then I'll click on OK. Now there was another element right over here, which I can simply select and delete in the AutoCAD from the AutoCAD file. Now in the front view, I've got my truss. In the workstream menu, we can see over here, these are all beam type of elements. So basically, beam type of elements are the line elements having 6 degrees of freedom. But we need these diagonals to be truss type of elements having only axial forces taken into consideration. So for that purpose, what we can do is simply go to the Node Element tab and change the parameter of the element type. So what I'll do is I'll simply select these line elements, and then from general beam, tapered beam, I'll make it to truss and apply. So that's all. We have got now over here truss elements as well as beam type of elements. The next part is to go ahead and create the rest of the structure. Like we would like to create columns, and further we want a 3D type of structure. So what I'll do is I'll use this extrude function, which is a very good feature, a very good tool in Midas Gen. With this extrude function, I can convert any node into line element. So I'll select these two side nodes and convert them into line elements. I'll keep the height as 4 meters, so minus 4000 mm, and I'll click on apply. So here we go, we have got one frame, and then I can further use this entire frame and translate elements into Y direction. This is X and this is Y, so in the Y direction, and I can provide the value of, let's say, 3000 mm, 3 meters apart, and I can repeat this translation or repeat this copy step for number of times. So this I can make it as 4 number of times, and then just click on apply. So here we go, we can further decide if we want to keep these columns or not. That can also be removed. Just by deleting these bottom nodes, we can delete the entire element because it is connected to the bottom node. So I press this delete from the keyboard, and then further I can create some beams by using the create elements command. In this command, the good part is that by clicking on one node and the last node, the nodes lying in between will divide the line element that we just created. So no need to worry about the intersection of the elements. So similarly, I'll create the beams, even the ridge beam. Okay. Midas Gen has got a very good feature, that is autosave feature. I'll save this file. Okay. Alright, and then further, as in the drawings, we can see there are purlins as well. So in case you would like to model the purlins and take the stiffness of the purlins into consideration, then you can definitely go ahead and model the purlins. If you do not wish to model the purlins, then the load distribution is also of not a problem. We do have a command, that is floor loads, which can include these unmodeled purlins into consideration, and those purlins can then further transfer the loads on the rafters. So what we will do over here is, in this session I will create the purlins. So we do have the nodes right over here. I'll just simply use the node to node connection. Alright, and we will be assigning them with the purlin material and section property. So now I'll go ahead. We are done with the node element tab, and we will now go to the structures, and we'll go to structure type. Now this is a 3D steel warehouse or shed, you can say. And then further, for assigning the seismic property, seismic analysis, seismic loads onto the structure, we need to convert the self-weight into masses. So I would have to check on to this option right over here, and since we are applying the lateral load in the x and y direction only, I'll apply it to x and y. I mean, convert the masses to x and y. Okay, that is it, and I'll click on OK. Next, we can always go ahead and check the duplicate elements. Now this is a very good feature in Midas Gen, wherein by just one click the program will not just only identify the duplicate elements but also delete them. So you need not worry of locating and then further go ahead and deleting them by yourself, making it a little bit of mess. So it is automatically done by the program. Then there are certain other editing tools that, like merging tools and intersection tools, that can check if your structure has been properly intersected and there is proper connectivity maintained. So now after the modeling is completed, I can simply go ahead with the properties, and with the material properties I can add, since British standards are used, we do have got BS. Even the latest code is there, and from the database we can select S275 and click on OK. So this is for steel, and then further we have got the section properties. So we'll have section property definition, in which we have got RHS and SHS, that is, we have got hollow box section. Now external members will be defined by using BS standard, and we have over here there's no 125 by 75 by 3, so I'll just take a close section property. So let me select this one, 120 by 80 by 4.8, And further, we can go ahead and modify these dimensions that are right over here by using the user. So this can be 5. We can modify this to 75. And the thickness can be further modified to 3 mm. Yeah, that's it. And we can click on apply. That was about external. I can go on creating the internal member similarly by selecting the new database and selecting from here the SHS, which is 75 by 75 by 3. So I can use this property. Change the name. Make this as 75, 75, and then click on apply. Then further we can create the section properties, or we can define the section properties for the beams and the columns and the purlins the similar way by using the database and so on. Then however, what I'll do is in case we do have got different types of section properties already defined in a previously created model file, then that can be simply imported by using this import tool. So I had already created them. Yeah, so here we go. We have got these imported these section properties predefined in a previously created model file. Now I have already defined the external and internal, so I'll put them in the unselected list, and this is a selected list. I've created beam members, column members, and purlins as well. Okay, so now the definition is complete. I would also like to show you that we have got value type of section properties. SRC is also available. Like we can have steel reinforced concrete beam created, where steel sections are encased in concrete. There is combined. These are all section properties. We can have tapered sections as well, and the program is capable of performing tapered design. And finally, composite elements can also be defined. So after the material properties are done, section properties are defined, the next part comes is assigning these properties to our structure. So what I'll do is in the workstream menu, I can see over here the material properties and all the section properties defined. The ones that are in blue, these are not assigned to the structure. So what I'll do next is I'll go ahead and assign the properties. Now assigning the properties is very easy. First, material property has been already assigned to the entire structure, so we are going to go ahead with the internal member. All I do is select all the trusses for internal members and then simply drag and drop. So I'll just give a closer look of this. So I just selected the truss and then just drag and drop the internal member. So the property has automatically changed. Similarly, I'll go ahead and provide the beam members property. So let's say these are the beam members. Then further the columns. So I'll just simply select all the columns like these. And then the purlins. So these purlins, simply I can select by making a box. So the purlins are selected and then just simply drag and drop the property. So as you can see, the purlin properties have been applied. Now the angle of these purlins also can be modified. All I have to do is simply select one side. Now they need to be aligned at such an angle. So I can go back to this node element tab, change parameters, and change the local axis of that element. by using this reference vector. So I provide the vector right over here. This is the direction, and I click on apply. So this is how I have easily modified the angle of the purlins. I'll do the same thing for this side. Okay, this one is not selected. Okay, so this is done. Our entire model has been created. Now the next part is the boundaries. So we finished with the first 4 tabs for the entire modeling. Then we go ahead to the boundaries, and we start with defining the supports. In the supports, we see over here dx dy dz. This is basically for constraining the translations in x, y, z direction. So if you want pinned connection or pinned support, then we can just simply click on D all right over here and select the bottom nodes and click on apply. So pin supports have been assigned. If fixed, then you can simply check on R all to constrain the rotations in x, y, and z direction. We do have this RW, which is for constraining the warping effect. Okay, so boundaries are done. Now we can go ahead with the loads. Now before we go ahead with the loads, it is important for the program to have the story definition for applying the lateral loads. So for that purpose, we'll go to Structures tab, and in the Stories, we'll say Auto Generate Story Data. The program can automatically identify the levels. All we need to do is modify them wherever not necessary. So these are the inclined locations. I'll just put them in the unselected list and click on OK. Now the good part in the program is that the program can automatically consider the rigid flow diaphragm. However, we do not want to consider the rigid flow diaphragm, so we can modify them simply by changing the column cell. Okay, now back to the loads. In Midas Gen, we can apply loads in many ways, like we can have static loads. That includes a self-weight, lateral loads, pressure loads, flow loads, element loads as well. Then we have got dynamic loads that has response spectrum loads, time history loads. We can also, in the time history, we can have dampers and isolators as well. There is temperature and pre-stress loads that we can apply. So in temperature, we can apply gradient temperature, and in pre-stress, that is post-tensioning and pre-tensioning, both can be done in the program. There is construction stage analysis. So often it happens that when we are erecting our steel truss, that time maybe the boundary condition or the support of the erection while we are erecting is different, and while we place the truss member it is changing. So this change in boundary condition can be simulated using the construction stage analysis, wherein at a time we can have one support and then that support can be deactivated and the new support can be activated. So the change in the stresses also takes place and reflected in the construction stage analysis because of the change in geometry stiffness. Now we'll go ahead. This is the moving loads. So in case of crane loading, so for gantry crane girders, we can apply the crane loading onto those girders. And the good part in the program is that the program will provide the location of the wheel because of which maximum reactions or bending moments or any displacement is taking place. And lastly, we have got the heat of hydration analysis. So in case of heavy foundations, like machine foundations could be heavy, mass concreting work is required to be done because of large depth of the raft foundations. So for such cases, the heat of hydration analysis is useful. In Midas Gen, we can have solid elements, and the good part is we can also simulate the pipe cooling system for the mass concreting works. We can also apply settlement loads and imperfection loads. So that is it about loading. Now in this model, I will be applying static loads. So in the static loads, I'll firstly define static load case of sulfate. That comes under dead load. A superimposed dead load, a live load case. I'll, as a demonstration, apply the wind load in X direction and earthquake load in X direction. Now we can of course understand while we are applying how to apply in the Y direction as well. For applying in the wind loads or earthquake loads in the Y direction, we need to have separate load cases. Now after defining the static load case, I can go ahead, define the sulfate. -1 would be the scale factor. Then further, I can convert loads to masses for seismic design and seismic analysis. So I can just simply select the dead load, apply scale factor of 1, simply select live load, apply scale factor of 0.25, and that's all. So this is a huge time saving function in Midas Gen as compared to other programs, wherein you can simply, by using the scale factors, convert the loads that has been applied onto the model into masses. Next, I'll start applying the lateral loads, and that I'll start from wind loads as I'm going from left to right and top to bottom. So wind loads I'll add. We do have British standard over here, PS 6399. And that we can simply select the site category, country or town, building type factor, basic wind speed, mean roof height. So we can provide over here, let's say separation of the building, mean roof height, let's say 10 meters, and closest distance to the sea, let's say 10 kilometers. And we can also include the wind speed factors that are dependent on the site. So altitude, directional factor, seasonal probability factors, topographical increments, or such kinds can be included over here. And then by simply specifying the scale factor, I can provide the direction to the wind load. So we are applying the load in the X direction only, so Y direction scale factor will be 0. If there is any additional wind loads that you wish to apply onto the model, then that can be done from this location. Now I'll click on wind load profile. As you can see, the story forces, story shears, overturning moments can be applied. We can also see how this pressure and the wind forces have been applied over here. So we can click on make wind load calculation sheet and see over here the formulae. And click on OK. So now the wind loads are applied and we can see the same over here. Now the next is seismic loads, EQX, and we have got all these standards available for applying static seismic loads. For now I'll be using the Eurocode and the ground type. Basically after providing the site specific parameters, we can go ahead with the fundamental period. Now the good part in the program is that the fundamental period can also be automatically calculated by the program. All you need to do is select the formulae suitable for your model. Then seismic load factor, again this is similar. We need to just provide 0 for the Y direction, and if we want to include accidental eccentricity, positive negatives can be selected, or if you do not want to provide accidental eccentricity, then none can be selected. By clicking on seismic load profile, even before the analysis, we can see the story-based shear. Now wind loads and seismic loads are done. We can apply the element loads onto our purlins, or we can apply the element loads on any of our members. Or we can directly go ahead with the assign flow loads command to apply the flow load or to apply the roof loading onto the roof, inclined roof. Now this is a very good advantage wherein we can include all the load cases at once. So this is a roof loading. I select the superimposed dead load of 0.375, and as well as we can include live load of minus 0.5 and add and close. Now to apply this, we can use one-way type of distribution or two-way type of distribution, but usually it is one-way type of distribution wherein the load is applied onto the purlins, then the purlins transfer the loads to the rafters. So one-way type of distribution. And then further, as I was saying, if we do not have the purlins model, then we can use these unmodeled sub-beams to transfer the load onto these unmodeled sub-beams first, like this, and then further these unmodeled sub-beams will transfer load onto the rafters. Okay, so here we have already modeled the purlins, so I'll go ahead and apply the area, flow load area. All I have to do is simply click on 4 points, and that's it. I have applied the flow loads. Similarly, I'll do it for the other side. So by simply specifying the area, the flow loads can be applied. As you can see over here, these are in the gravitational direction. We can modify this direction by simply changing this global Z to local Z. Alright, so after this is done, then we can go ahead simply and perform the analysis. Alright, so our analysis has been completed and we see over here certain warnings. So these are because of, firstly, there is some singularity error that is there. This is because at this location the rotation is not being able to be transferred, so the warning has been provided for that purpose. Further, the displacement error is there, so we can check then where the displacement is going wrong. We can simply go ahead to the results and check the deformations by using this sulfate, and we can click on deform and check the legend. So the deformation is actually within control. Now, for the live load, it is not. Let me check with the load that has been applied. Okay, this is in kilonewton per mm square. So of course the loads that have been applied are really high. I'll just change this unit system to kilonewton meter, and we can simply modify the flow loads by changing the values over here. 0.375 and 0.5. Modify. Okay. Yeah. Now we got just 10 warnings, and those are regarding these singularity errors. Okay. Okay, so these we can ignore as these are to act as trusses only and not beams. Okay, so after the analysis has been performed, then we can go ahead to check the results in the next tab itself. So for checking the results, we can now go ahead and create the load combinations. So load combinations basically, instead of being in the pre-processing part, we have in the post-processing part, so that less time is required for the analysis procedure. Load combinations can be generated by using the General tab. We can specify the steel or concrete standard, and then over here we can have the envelope to see what is the maximum value out of all the load combinations. So I selected BS8110 as suggested and I've clicked on OK. So strength as well as serviceability load combinations are created, and we can see over here the envelopes of both. Now steel. For performing the steel design, we need to have the load combinations over here. I'll click on auto generate. However, we can see over here only the steel standards, and that is BS5950 that we see over here. But we need to go ahead and create these load combinations which come under the concrete design. So all we need to do is simply go to concrete design, click on auto generate, select the BS8110, click on OK. Then we can go to the spreadsheet form, select all this area of the load combination definition, copy, like I've simply pressed Ctrl C, and then go to steel design, click over here on one cell and paste it. So this is how easily I have created the load combinations. Further, there are some descriptions as well which also can be copied. Now the good part in the program is that with these descriptions we can understand easily what is the load factors applied. So these are the load factors right over here which we can modify by ourselves. Alright, so by looking at all these load combinations, the program is going to perform the design, the steel design, and that's what we'll do. Before going to the design, let us check with the results. The results we can start from reactions. The reactions where supports have been provided, and by using the envelope of CB max, we can see the vertical reaction and display the values onto the structure. So this is the vertical reaction that we have. And then further we can see over here, this is red arrow, which means that maximum reaction has been obtained here. Alright, then looking at the displacement contour, I'll use the serviceability envelope and deform the structure and check on only maximum value. So I can even check on the legend and animate. So we can see over here the maximum displacement is 170 mm at these locations. Okay, I'll stop this. Now let us see the truss forces. So I'll check on all the values. I'll use the shrink and I'll go to the front view. Undeformed, legend not required. So we can see over here the forces in the truss members in kilonewton. We can get the results in the form of tables as well. All we need to do is click on this three-dotted box beside any result. and then click on the load combination we want to check the results for and click on OK. These tables that we get in Midas Gen are Excel compatible, so we can simply select them, right click and say copy and paste it into Excel sheets, or we can even directly say right click and export to Excel. We can also see the beam forces and moments. These are the moment values. You can see the beam diagrams. Fx is the actual forces. So this is for the first load combination. And in this way we have seen the results of Midas Gen for our roof, for our truss. Now the next thing we'll do is go ahead to the design results. In the design, we can go over here in the general parameters and check the definition of frame, raised, braced or unbraced, and in Midas Gen we have the option to auto calculate the effective length factors. Then further, the member type. Now in Midas Gen all the horizontal elements are designed as beams, vertical elements are designed as columns, and inclined elements are designed as braces. So if we want to design our rafters as beams, then we need to select them, and then I'll just simply activate the second workstream menu. Yeah, so I need to just simply select them and then change their type as beam. So the external members, they are converted as beam type of member, and then the program is going to design them accordingly. So now all I have to do is select the design code, that is BS5950, and then go ahead and perform the steel code check. So the program has kept over here, as we see, certain elements. Those are purlins basically. Those are cold form sections, so we can design them over here. In case of our model, we can see over here the steel code check has been performed. By property, we see if the most critical member has passed or failed out of all the members in one section property. So we see over here, this is in red, external member. So the section property is not adequate for our external member. And we can see over here by members which all elements are failing. So I'll just go to the asymmetric view, and from here just click on not good and select all. So these are the elements which are failing. We can even check why they are failing by using this graphics output. So in the graphics output, we can see over here they are failing because of the bending in the Z, local Z direction. And so the combined capacity, tension plus bending, is also going beyond the limit. So what we can do in that case is select this particular section and click on change. When we click on change, and then we provide here the information from where it needs to select the section property from, and the size, shape also, which we can modify, but I'll keep as same. Then the limiting load combined ratio, this we will keep it from 0.7 to 0.9. And then we'll click on search satisfied section. The program will automatically search out of all the section properties available in BS standard. All we need to do after that is simply select one of the property and use it. So in this case, we can, let's say, select 150. Also, if we do not want to select out of these or out of the standards, then we can just use the previously created model file wherein your own root or wherein your own section properties are there. So open MGB file that can also be used for searching the most suitable section property. Right now I'm using the standard, so I've selected 150 by 100, and then I can just simply click on change and close. So we check on this and then we click on reanalyze. So even after changing the section property, the program can reanalyze, and then we can go ahead perform recheck. So in the recheck we can see that the demand capacity ratio is 0.928 for the external members and it is passing. We can even look at the detailed report of the design that has been performed. So the report in Midas Gen is also a very good advantage, wherein we can see the clauses, we can see the sections, we can see the tables and all the references from the codes, all the formulae from the code, and that's how it'll make it easier for us to verify if the design provided by the program is correct or not. This then further can be taken as reports. So this is not only for one section property, but for all the members the program can provide with a detailed report. This was about section code check. Next, I would like to talk about the steel optimal design in Midas Gen. So over here we can see, let's say, the beam and the column members. We would like to modify these two members, and we would like to see if any lesser section property would make the structure economical and also safe. So we will just check on these two, and then there is analysis option, and the program can perform iterations, number of iterations, to find out the most economical section property. So that is under our control. We can tell the program to make 3 iterations and then further perform the design and analysis. So it says the section is not changed. That means by changing the section property one time, the third time it did not think of changing it further, because no other section property was making it more optimal. Now before it was 203 by 102 by 23. It's the same for the first time and the second time, but as we can see over here for the columns it is 203 133 30. So it has modified that, and we can go ahead and use this graph report and check if the optimal design has been correctly or if it is satisfactory. User defined section database. Provide the shape information and the dimension information, and then use these sections to perform the optimal design. So this is about the optimal design in Midas Gen. Now I would like to take you to Midas Design Plus. This is Midas Design Plus right now, and we can go ahead and perform component design of beam plus column, base plates, bolt connection, crane girder, purlin, girth, web opening, staircase, like that. So here we have got the code. ACI, we can use metric system, we can use the British Standard Material property and the section property, and click on apply. Alright, so now we are going to go ahead and perform the base plate design. So in case of steel, we'll go for the base plate as an example for our steel shed. And here we can also go ahead and link our Midas Design Plus to Midas Gen, so that the the analysis results from Midas Gen can be taken directly into Midas Design Plus. So I'll just select the node and import it over here. So here I have got the information of the forces as well as the information of the shape. I can also include the pedestal. I can use rib plates, or there is wing plates also that we can use. And then further, this is the position of the anchor bolts. I'll just modify this into SI unit system. Alright, and the material for the plates, I'm keeping it as default. And then further, we can just simply click on design. So after click on design over here, the program will provide the calculation results, the demand capacity ratios, the criteria, and the value. So it has taken as this distance, and it does not require much a big plate as such for such short small forces. So further, we can go on reduce the size of the pedestal as well, and or we can simply change the widths over here to 200 and 300, and then we can perform the check. So it's still satisfying. And then further, Midas Design Plus can also provide us with a very good detailed report. And this detailed report that we get from Midas Design Plus is in the form of a Word file. So here we go, we have got a Word file created with images, forces, finite element results of the bearing stresses, tension, then base plate moment diagram in X and Y direction, shear force diagram, anchor bolt check, tension forces not exist. So this is how detailed report we can get in Midas Design Plus for the base plate design. Midas Design Plus can also provide drawings. So as we can see over here, this is the workspace which can follow all the commands of AutoCAD, and we can further save this as .dwg file format and further give it to the draftsman for making any changes or copying and pasting into a certain layout. So that can be done. So this preliminary drawing is provided by the program itself. So this is it about Midas Gen and Midas Design Plus for steel truss.